Right, this lesson is going to be a quite important one in integration because this is the first hurdle that a lot of students will find integration disgusting, difficult. Reverse chain rule 1. Now, this is a concept, not in a skill, not a formula to follow. So that's why sometimes people will find it difficult to sort of understand what's going on in here. Now, you've learned about chain rule in differentiation. Now, in integration, we can only do reverse chain rule. So start the question, can I ask you use chain rule to differentiate this? If you remember the shortcut for chain rule, can I ask you to go through this question? Okay, pause the video, okay, have a go at the start the question, and then try to answer this if you can, okay? Then when you're ready for the answer, you can press play. Okay, so we know chain rule, okay? Differentiate sign, different outside to inside, that's a shortcut. Differentiate sign is cos 3x plus 1. Differentiate inside is 3 times it by 3. So it's 3 cos 3x plus 1. Okay, that's chapter 9, okay, 9.3, 9.3.5 for chain rule. Now, if I this time want to reverse it, okay, what about if I integrate cos 3x plus 1? Now, if I differentiate sine 3x plus 1, I get this. Therefore, if I want to integrate, I reverse the process, then I should get sine 3x plus 1. But what's different is there's a 3 in there. So if I want to do it backwards, it will be a third of it and plus c. And that's reverse chain rule. Reverse chain rule means we are going to consider what function that if I differentiate, I can get the function inside the integral sign. So in here, what I'm trying to say here is, let's say we integrate cos 3x plus 1. Now, we're not going to integrate cos 3x plus 1. Instead, we're going to think what differentiate give cos 3x plus 1 and then reverse the process. Okay? In a very simple one, like times and divide, imagine times is differentiation and divide is integration. Okay? Think about this. If I have to do 63 divided by 9, now that's integration. Imagine if I need to work out 63 divided by 9, I'm not actually working out 63 divided by 9. Why? Because I'm actually working out 9 times what will give me 63. So this is the kind of concept we're talking about in here. We're not thinking about, how do we divide? How do we do 63 divided by 9? Instead, we're thinking opposite way around. 9 times what will give us 63. Okay. So for example, in here, we're not integrating cos 3x plus 1. We're thinking about what differentiate what will give me cos 3x plus 1. Okay. Now, this concept will be quite hard to grasp, but we'll go through a few examples in here. Hopefully, you try to get the idea. Okay. Example. Okay. Find the following integrals. The integral of 1 over 3x plus 2 dx and b. Okay. So let's look at one by one. Okay. A. 1 over 3x plus 2. First question is, okay, I'm going to write in green, okay? This is the sort of the thinking process, okay? Your thinking is, okay, what differentiates will give 1 over something. Okay, so what differentiate will give 1 over something? Well, if I use what I've learned last lesson, I know differentiate ln x will give us 1 over x. That means differentiating ln will actually give us a fraction. So the answer to this is maybe ln. So here's our trial and error. Okay, so we're going to let y equals to ln 3x plus 2. Now, where did it come from? I'm guessing differentiating ln will give me 1 over. Therefore, let y equals ln 3x plus 2. This is my guess to the answer. So I'm guessing integrating 1 over 3x plus 2 will give me ln 3x plus 2. Or if you like the comparison of dividing and multiplying, what I'm trying to say here is, for example, if the question asks me to do 63 divided by 9, I'm thinking about, okay, let me guess. I know 9 times 6 will give me 54. Therefore, 9 times the next number should give me 63. So I'm guessing, okay, 7. So what I'm trying to say is I'm going to try let y to be 7. That's my guess, okay? Now, when you guess something, you have to verify it. Okay, so how do I verify it? Verify by differentiating. So let me try differentiate. Okay, so dy by dx. Differentiate using chain rule. So this chain rule, okay, chain rule. Differentiate ln is 1 over 3x plus 2. Now, hence the importance of knowing how to do chain rule, the shortcut, in a very short time, because you need to chain rule is something you have to use it, rely on so often. So differentiate ln is 1 over. Differentiate inside is 3. So that's 3 over 3x plus 2. So this step is to verify my guess. Right? So the question is to integrate this one. Okay. My guess is that if I differentiate ln, it will give me back to the 1 over 3x plus 2. Now, my guess is not completely wrong, okay, because you can see it's 3 over 3x plus 2. Instead of 1, I've got 3. Right? So my last step is that therefore, right, the integral of 1 over 3x plus 2 dx equals 2. Now, if I differentiate ln 3x plus 2, I get 3 lots of 1 over 3 lots of 3 over 3x, 3 lots of 1 over 3x plus 2. I only need 1. Therefore, my answer has to be a third of my guess, a third of ln 3x plus 2 plus c. And that's the final answer. And then this next step in here is to balance the coefficients. That is from 3 over 3x plus 2 to 1 over 3x plus 2. I need to times it by 1/3. So it's 1/3 of my guess answer. So it's 1/3 of my guess answer, not 1/3 of 1 over 3x plus 2. It's 1/3 of my guess answer. That's why this step is important. The first step, y equals ln 3x plus 2, because that's the guess. Okay. Obviously, you have to guess it right. And this guess it right come by experience, also by practice. So, okay, so 1 over 3 and then 3x plus 2. You can try differentiate. We can try differentiate. Okay, this is not required, but let's try differentiate this. Imagine, okay, so let's try differentiate this. 1/3. Differentiate ln is 1 over 3x plus 2. Differentiate 3x plus 2 is 3. Therefore, it's a third times 3 over 3x plus 2. 3 and 3 cancel out. It's 1 over 3x plus 2. And that's why the integral of this. Okay, so that's how we know it's 1 over 3x plus 2, and we know it's correct. That's how you can verify. You can verify by differentiating the answer. Right, let's try one more. Part B, 2x plus 3 to the power 4. So part B, integrate 2x plus 3 to the power 4 dx. Here's a guess. Okay, so again, the inside conversation in my head, what differentiates gives something to the power 4. Maybe you can ask yourself the question, what differentiate something? Okay, what differentiate give you power 4? The answer is power 5. Because when you differentiate power 5, it will bring down the power down by 1, become power 4. So, okay, so I'm going to let y equal, I'm going to guess my answer to 2x plus 3 to the power 5. Because when I differentiate power 5, it gives me back the power 4. So this is my guess. Okay, so this is my guess again. Now, this is not a random guess, okay, that you're going to go to the lottery and try to, okay, let's think about, okay, let's buy lottery and hopefully this will be the jackpot. No, okay, it's by educational guess that you will know differentiate power 5 give you power 4. So let's differentiate dy by dx, differentiate it, okay? So differentiate, chain rule again, power 5 first from the outside to the inside, differentiate outside is power 5, so 5, 2x plus 3 to the power 4. Times, don't forget the inside, like the onion, will make you cry, 2x plus 3 is 2. So therefore, it's 10 bracket 2x plus 3 to the power 4. So is my guess completely wrong? No. What? Because my 2x plus 3 to the power 4 is matching with the question. The only difference is the coefficient is different. So this step is to verify it. And the next step, if you look at the previous step, after differentiate, I realize my answer is not far off from the question. I need to balance the coefficient. So I need to balance the coefficient. So therefore, the integral of 2x plus 3 to the power 4, I'm going to rewrite the question, equals to, the question in the front has no 10. Therefore, it'll be 1/10 of my guessed answer. My guess is 2x plus 3 to the power 5 plus c. This step is to balance the coefficient from 10 to 1. Therefore, we have to multiply by 1/10. Okay, so hopefully you do have some idea in here. Now, what I want you to do next is, if you're happy with what I just explained, I would like you to skip the example for now. I'll come back to this. Skip this. Have a go in a practice question, question 1 and question 4. Okay, question 1 and question 4 first. Pause the video, have a go question 1 and question 4. When you're ready for the answer, you can press play. Okay, so for question 1, okay, you would let y equals 3x plus 4 to the power 4, because differentiating power 4 gives you power 3. So you go on and verify dy by dx, which gives you, oh, actually, why do I do this? I'll give you the answer first, just in case you got it right, then you can move on. So the answer of question 1 is 1/12 of 3x plus 4 to the power 4. Don't forget the plus c, the child, and the question 4 is 1/130, 10x plus 11 to the power 13 plus c. Okay, if you got it right, well done. They can move on to the next part. So if you don't, let's go through them. So differentiate this one, differentiate from the outside to inside. Power 4, 3x plus 4 to the power 3. Differentiate inside is 3, so that's 12, 3x plus 4 to the power 3 plus c. And not plus c, so not plus c in here. So I can tell my algebra part is matching with the question, so I know the reverse chain rule works. My last step is just to rewrite the question and to balance the coefficient. From 12 to just 1, I need to multiply by 1/12 of my guessed answer, 3x plus 4 to the power 4 plus c. Now, if you don't get it, treat it like an example as well. We're going to do lots of practice on this one, because this is, again, the #1 big hurdle integration. We must start off in the right foot in here. It's going to be important that you know how to do this. We're going to rely on this further, more and more in later integration. So Lego, if you got off the wrong foundation, your whole thing is going to topple. So question 4, same in here. We're going to let y is power of 12, so we're going to let it to be power of 13. dy by dx, let's differentiate, verify it. Take down the power of 13, power goes down by 1. Differentiate inside is 10, so it's 130, 10x plus 11 to the power of 12. It works, but the only thing is there's no 130 in the front. Therefore, the integral of 10x plus 11 to the power of 12 dx equals to 1/130 of 10x plus 11 to the power of 12 plus c. What mistake have I made? 12. It should be what I guess. So this should be 13. I deliberately put it in, make the wrong mistake. Deliberately. Of course, every mistake I make is deliberate. It has to be a guessed answer. Okay. Now, let's move back to this one here. Example, e to the power 4x plus 1. How do I integrate e to the power 4x plus 1? Well, think about when you differentiate power of e, what's so special? Itself always comes up again. Yeah, so when you differentiate e to the power 5x, e to the power 6x, e to the power x squared, the e itself always comes back in the final answer. So with e, we're going to let y to be just the e itself, because I know by differentiating e to the power of something, my final answer will always have the e to the power of something. That's a special case, I guess. So differentiate dy by dx. Differentiate e to the power 4x plus 1 with differentiate power, which is just 4, so 4 times 4x plus 1. Next, so this might, again, my guess. This step is to verify. And I know my verifying I know my reverse chain rule works because that's the same as the original question. Therefore, the integral of e to the power 4x plus 1 dx equals to, there was no 4. So I have to multiply by a quarter of my guessed answer and the child. All right. Next one. Example. What about sec squared 3x? So you need to open your formula booklet. Okay. Tell me what differentiate to give sec squared. Okay, open formula booklet. So what differentiate give you when you differentiate give you sec squared? So 10x, when you differentiate 10x, you get sec squared. Okay, so therefore, what we're doing here is we're going to let y equals 10 3x. Now, please write in here where 10 3x come from. Okay, you will say because in the formula booklet, okay, in formula booklet, we know the derivative of 10x equals sec squared x. That's why we're going to let y to be 10x, because when we integrate sec squared, the answer should be something along the line of 10x. So let's differentiate. Let's verify it. So dy by dx. Differentiate 10kx is 3 sec squared 3x. Does this reverse chain rule work? Yes, because you can see this term is matching with the question. So therefore, the integral of sec squared 3x dx equals to, let's balance the coefficient, is 3. The question only has a 1. That means it's 1/3 of my guess answer, 10 3x plus c. Okay. This common mistake student will usually make, like what I did in the practice question just now on, is a lot of students sometimes they will write the sec squared 3x back in. But remember, most likely your integral will be different to the answer. So remember to write down the y value instead. It should be the y function. Okay, 1/3 of your y function plus c. Okay. Now, if you're happy with what I mentioned here, I would like you to have a go at question 2 first. Question 2. Okay, question 2. Pause the video, have a go at question 2. When you're ready for the answer, you can press play. So the answer to question 2 is 1/5 cos 1 minus 5x plus c. You got it right? Well done. Move on to question 3. But if you don't, let's go through why. Question 2. So what differential gives sine? Well, what differential gives sine is negative cos. So it'll be negative cos of 1 minus 5x. Because differentiate minus cos will give you sine. So let's dy by dx. Differentiate negative cos. Chain rule again. Differentiate negative cos will give you sine 1 minus 5x. That's fine. Time differentiate inside is minus 5. Therefore, it's negative 5 sine 1 minus 5x. And we know it works because sine 1 minus 5x is there. We just have to balance the coefficient. There's no, we're comparing the 1 with a minus 5. Therefore, the integral of sine 1 minus 5x dx equals to negative 1/5. Why negative? Because there was no negative in there. So we're multiplied by negative 1/5. Okay. Next, of the y function times negative cos 1 minus 5x plus c. The minus cancels out, becomes just a positive 1/5 of cos 1 minus 5x plus c. Right? So 1 minus. So if you're happy with it, have a go at question 3. Now, you can pause the video now, have a go at question 3. If you struggle with it, the next time when I play the video, it will be a hint. Okay, so pause the video, have a go at the question. When you're ready for the answer or the hint, you can press play. So if you struggle with this, okay, here's the hint. First, I will help you to remove the 1/3 outside bracket, because remember, if you can remove the coefficient, remove the coefficient. So it's 1/3 of the coefficient of 1 over 4x minus 2 to the power of 2 dx. Next, I'm going to write the power of 2 underneath as a negative power, because we know with integration it's best to use negative power for integration. Power of minus 1. Oops. Minus 2. Minus 2. Minus 2. Okay. Now, think about this. Okay. Here's the hint. What differentiate give you power of minus 2? Pause the video, have a think about, okay, what differentiate give you power of minus 2? When you're ready for the answer, you can press play. The answer is on the left-hand side, okay? The answer is power of minus 1. So we're going to let y to be 4x minus 2 to the power of minus 1, because differentiate power of minus 1 give you power of minus 2. So we're going to dy by dx. So what about a third? We're going to leave it out for now, because third is a coefficient. It's nothing to do with integration. We can just multiply a third at the end. So dy by dx, differentiate that one. So bring down a power minus 1, minus 1 becomes minus 2, times differentiate inside is 4. So they give you minus 4x minus 2 to the power of minus 2. We know it works because this variable, this function, is matched with the question. So what's the integral then? What's the final answer? We have to balance there. Therefore, the integral of one third of 4x minus 2 to the power of minus 2 dx is the same as, now the third outside, we're going to rewrite it 1/3. Okay. Now the integral of 4x minus 2 to the power of minus 2, we're comparing a 1 to a minus 4. We're comparing a 1 to minus 4. So we have to multiply by a -1/4 of a y function, 4x minus 2 to the power of minus 1 plus c. And that gives us minus 1/12 of 4x minus 2 to the power of minus 1 plus c. Right. Now this is sort of the hardest one to do, not only because of negative power, but also we are just comparing, we've got more than one coefficient. The coefficient 1/3 has nothing to do with it. You can see the 1/3 is just outside. So we're always comparing this coefficient with that one. The shortcut to remember this coefficient is just do the opposite of this. If there's a fifth, okay, if there's a 5, do 1/5. If it's -5, do negative. If it's a -5, do -1/5. If it's -4, do -1/4. If it is -3, do -1/3. If it is a half, do 2, because opposite half is 2. Okay, so we'll do a lot of practice on this one, and that will be the end of this lesson.